Okay, come back and continue about our subjects. Although these things are not the current task or the future task because tomorrow I will participate in the math competence, but I learn nothing about the mathematical lab 12, how to solve PDE, and some very professional tasks. But I think anyway, just go direct. What I can do now is just to, to have a review about the internet protocols and networks. And it's just about the in the morning, just 3 or 4 hours ago, how time is fly. We have a quick review about the IP network, and now it's time for us to have a quick review about the transport law. Let me know about this structure, yeah, and from top to down, and IP is the network part, and transport law, and network law, and data link law. IP is just this is a quick review about the whole picture, and now is transport, network, and data link, and so on. So it is a opportunity to help you. What is the transport law? Oh, I just mixed up about the data link. What is the data link mean? And transport, I think, is just to write the something to the switch. Oh, there are three types. That is the router, switch, and repeater. Router is in the transportation law. No. Router is in the network law, and the switch is in the data link law, and the repeater is in the physical law. And the transport law, I think basically transport law is a little bit tricky from the application to enter to the network. So how to enter its user transportation and some protocols like how to write the packet to the router and then router to route direct. So I think what we will learn in the transport law is just about something like the first thing in the process, how the process of networks works, how it works, like the first thing the application to be split and transform into the packet. Then however how the packet does packet uh, how does packet transform to load into the switch and to the router and then switch and so on. So the transport also, the first is about the process, the second is about the mechanics. I mean the detailed protocol, like what kind of strategy we use to have a high efficiency and so on. Okay, the third thing, I don't know what I have learned. Maybe this is just the two key points, or maybe the third thing is just something like in the whole picture, what is the importance of the transport layer and its the role to value the role of a bridge, and just try to learn about it. Transport law. Continue on. shouldn't lose time. Please do not please do not throw out the sausage. Please do not throw sausage piece away. Physical data link, network, transportation, session, presentation, application. And this is our goal. Okay, this is just the goal. The principle. Okay, this is typical principle multiplex demultiplex. This is just what I have mentioned about the strategy and the transportation. Learn about the internet for transport law protocols. It's also about the transportation. Okay, I think this is just more like a process, and this is just like a strategy. Connectors, connectionless transport, connection-oriented, reliable transport, TCP congestion control. Okay, that's clearly multiplex and deep multiplex. It's just something like how to. It's just multiplex means that we receive from different directions and demultiplex and to give out the information into different directions. It means reliable data how to guarantee it's reliable and flow control. It what means that we need some mechanism. Oh, they are different because what is flow control? Flow control means how when the lawyer don't want to get so many packets. So how to control, and congestion control means that when it comes to many things, how to deal with these things. So the first thing is the flow control means object I can control. I am the first person. Congestion is that I am the second person. I mean that I don't know how the first person, second person position. I mean that I am subjective or the negative. I don't know how to express well in English about learn about uh, internet transport law protocols, UDP connectless transport. Learn about internet transport law. UDP, and this is just mechanics like they are more detailed uh, about the separation. Okay, I think a good way to learn is just to be a class test and just to be positive to output. Okay, let me look. UDP means that there are something like we just output to not don't care about the other things and don't care about whether it received or it has received or not. The teaching means that if you have get it and then you feedback me and then I will go another, and there are something to speed up the and then to raise the information efficiency that it when you get it when your feedback doesn't come, I continue to send when I send the feedback that you can't receive, so I just repeat. And so these are just one of the mechanics, and the other strategy. I think this is just a model that is to send message or send email to others, I think. And oh, I just can't remember well. So this is a very briefly to general application law. This is covered many other models you will take. Network. This is the law you mostly work with as a programmer. And the application law is a network is abstracted away and you access a stream of data that arrives at a socket. It's up to you to define the format of data. Different application file transfer hypertext transfer protocol, file transfer protocol, send mail transfer internet message access protocol. Send an internet message access socket. What is a socket? The process sends or receives message to or from its socket. Process sends or receives message to or from its socket. Socket is analogous to store. Setting process shows message out door. Setting process relies on transport infrastructure on other side of door to deliver message to socket at receiving process. Process sends or receives message to or from its socket. Focus. Be water. Like water. Friend, my friend. Sockets. Socket analogous to the door. What is socket? And I think I shouldn't narrate, but to just try my best to memory, and not memory, just to review. So what is socket? I think it's just like a door, and where is it? It's just like I don't know. It's so abstract. Oh, these are just something. Oh, I think this is just something between the just to adore a transformation that is object as a gate. I think addressing process to receive message process must have identifier includes IP address, port number associated with process on host. To receive process must have identifier. Process must have identifier host the device has you must have identifier 3 Unix 32-bit IP address. Identifier includes IP address, port number, to send a HTTP message to get IP and port number. Does IP of host runs suffice for identifying does IP address of host on which processor runs? It's many can be running on the same host. What is the meaning? Many processors can be running on the same host. Many processes can be running on the same host. Does the host runs suffice for that? No. For different address in TCP, physical address, physical is just like LAN and data link. Link address, link LAN, local, and this is the logic address law that is application port application specific noise step and that. So I think these are just saying what is the logic. The logic is we will talk about the application layer and the transportation layer. So we from top to down, and then we talk about socket, and then we more additional about the address, and the AppLoy protocol defines the app app protocol. AppLoy protocol defines the types of message exchanged, message syntax, message syntactic, message about the message type, syntax and semantics, and the rule for when and how process and send and respond to open brown device in RFC request for comments and HTTP properties, protocol, Skype, session and presentation. Employ types of message exchange, message syntax, open protocols, properties, proprietary protocols. Session plus presentation noise. Session and presentation noise is theoretically not implemented in the internet. Session takes care of the connection between two hosts for the lifetime of that. It's a little abstract. Now I think the first thing is that I don't narrate. I don't need to narrate, but the first thing is that what I will learn and to guess what I want to learn, and then to and what I want to learn, then to check, and then to just to implement. Session and presentation line. So the first thing is that what will they do, and what we have and the position in the network log. First, they don't implement. They are not used nowadays. And what is the session? Session means that takes care of connection between two hosts, take care of connections and authentication. Who is your and what is kind of the presentation transfer is that translate data for application, transport data and care connection. It is a verification the connection and the translator. One is the placement to check, the other is the translator. Authentic and OSS is about the session log, send and receiving is about the application log encoding character set. Encoding, I think encoding characters are not converting bits to the signal is the data link log. From the physical to the data link log and encoding characters that encoding translate encoding translate data for an application. I think it's maybe about the presenter encoding. I think it's just presenter. Okay, here we go. We were talking about the transport layer. There are two parts. The first part is about the transport layer. What we will learn. The first thing is that there are two things: the process and the strategy. Okay, the 3.1 transport layer services, multiplex and demultiplex. I just think it's a little bit not a very clear logic, but just some heap. I think a lot of message to this heap. Transport noise. Okay. Function-oriented transport TCP. Okay, transport layer service. The services. Okay, just focus on the small part, and then to the whole picture. I think the whole picture too messy, and we will waste a lot of time. But from the little part, we can nail it. The first thing about transport layer, what they will do, and the process, and then some detail part like the multiplex detail. Then about one kind of the, it's about the UDP, and it's just about the principles of reliability. Okay, the process is what is the services from the application uh, to the network. So we should the packet register. We have some information, and then to load to the router. Load to the router. I think the service is just load. And there are one thing is logic and transfer logic communication. Okay, the first thing is that the logic communication between app process running in different transport. Okay, there are many important things about transport protocols run in and systems. Send side breaks app message. Okay, there are two different break message into segments. Here we call the information call them segments, but in the application we call them packet. In network we call them packet. Very easy thing, and support. Let's have a quick view about network logical communications between this. Okay, the first thing is about the logical communication between the process between hosts. What is the meaning of the process and the host? The logic between app process relies on enhances network service. Rely on enhanced network law service. How's analogous way? Okay, the sentence is children, children. The tell kids in Anne's house, sending letters to Tony's house, kids to children in Bill's house, and the household is just like the house. The house is just like house, and the process. App message is just a letter in the envelope, and the transportation people who gives network like the postal services. Okay, transfer house to house and the transport. Oh, this is very clear and analogy. And Bill who gave letters to correct children. Who gave letter? Oh, oh, I know the essence that is to say the noises is just in the local in this local group how to control and how to control then give the to give out the um, correct children. Okay, let's enhance this understanding. That is to say, what is the transport protocol is about relies on the process and what is the meaning process that is to say we just do something and like it and the right to after the network the lower part and then we lower part and then in the transportation we just know we get this house so the detailed split is to just divide them into different cases. But in the network that E2C, we get a great segment and oh, how to understand resemble. Okay, I think one thing to also about is that we also need more work like resemble them to the resemble is just to assign different letters to different kinds and what is the break is that we had task day so the end have task that is to say application this game will play game and so the protocol means that we just break the whole letters to different 12 letters and to segments and then provide and then to network. Okay, I know the essence reliable and what is TCP the trait of TCP we can get uh, it's reliable and TCP means the transport control process unreliable unordered reliable in order that we have different control like the congestion control and the flow control unreliable, unreliable, best effort. Okay, we should. What is the best effort? Oh, try my best. But what is TCP? TCP means we get the congestion control, flow control, connection set up. Service is not available. Service is not available. We cannot guarantee the delay and bandwidth guarantee. So, how to remember? Please don't understand. I don't think when we talked about the multiplex and demultiplex, I just think this process very simple. I think just to for the transport layer um, application, just you to multiplex the different parts of the segments that to the here, and then for the receiver we just demultiplex and based on the header information. So I think there's nothing we will talk more. So max combine services into data single example you form is about the max support it. Okay, this is what we have learned. Okay, this is just the header sender from the multiplexer and sender and socket in and okay. We need to do more things not only about the to from multiple sockets and we need handle and transport header and to deliver when just with the socket we neglect the socket. I think okay. Also we should refer that the process means what? How demultiplex and just some headers to different port, different IP. How host receive them each diagram has source IP, destination IP, TCP, UDP segment format that is source for destination port, uh, source and destination and education and so on. IP address and port address. Title multiplex combine several marks on D for the DMARCs, DMARCs, connectionless, multiplex. Why we can use, what is the meaning of the connectionless DMARCs? Datagram socket, my socket, one. One host receives UDP segment. One host receives UDP segment, checks the destination port in segment destination port and segment direct UDP segment. Why is the same? I don't know what is the meaning of same. Okay, this is just some question. I think it's very easy thing. Source and destination. IP address with same destination but first source region and or I think there is no doubt. I think it's a little tricky. Or connectionless, there are different two types of the demarcs. I just know that demarcs is just to split the information to different uh, to the different destination. But maybe I think I should dive deeper. Connectionless demultiplexing. One host receives UDP. Yeah, I know the one. Oh, I know the meaning. Different come from different IP, but the same port, so we can get to the same destination. So easy thing. It's just the common logic, but why it describes so difficult for me? Okay, there's a connection. Why it call it the connectionless? Because we just if we have IP and port, we can do. We don't have connection, but if we want to connection oriented DMARCs, so we can get only the use all the four values source and depth, both the depth IP, depth port, source IP and source. Only them could construct the bridge. Several hosts may support many simultaneous TCP sockets. Each socket identifies its own 4-tuple source IP source. Web servers have different sockets for each connecting client. Non-persistent HTTP will have different sockets for each request. Web servers have different sockets. Web servers have different sockets for each connecting client. Why? Non-persistent HTTP will have different sockets for 3 segments all destined to IP address B. Oh, these are just different things. I know the difference, just the one line, 2 lines. This is just only one line. 3 segments all destined to IP address B. Multiplex etc. Just only one socket, so there are more. I think the very thing, what is the logic? The logic is that we just use the different information to divide them into different groups, and what is the difference? The difference of the strategy. I think it's more strict for the connected oriented. Connection on the oriented. I think there's not many things to talk. Thread server. Okay. Thread server. Typical port numbers for applications. OK, port 80 standard port 22, SM for 443, secure HTTPS 8 HTTP SSH. Okay, the true or false. Multiplex if web traffic is received, demultiplex in current in a connection oriented demultiplex only one process can receive. Only one process can receive data set to a only one process can mean sportsman. I don't think so. For it true. Yes. I just think the B is not right. The AB is not right. I don't know. Connection use UDP. So we will trying to how to introduce about the UDP, what is the UDP and the mechanism like we understand and we don't receive. Okay, we just talk it into in the field of the transport law. It's about the process to process and it what it is doing it is just what is the work of the protocols I just they are do something like okay, when later comes, we just some mechanisms to the smaller range that is to like the package, how to deal with the package and the segments. These things I think so abstract a concept I have output. User datagram protocol. User data user datagram protocol. Simplest usable best effort. What is the best? The high efficient, the most simplest. Um, don't guarantee the order, don't guarantee the lot, but it's the simplest and high speed. Oh, okay, the best effort. The connectionless, no handshaking between UDP sender and receiver, can set immediately without asking first. Each UDP packet handled independently of others. Independently, UDP use multimedia. Okay, this word, multimedia, low store rate sensitive, streaming multimedia apps, low tolerant, rate sensitive, and use the DNS domain name system SNMP. I don't know what it is, SNMP. Streaming multiplexing, streaming multi, okay. Loss tolerant, rate sensitive, okay. Reliable transfer over the and reliable. Okay, we have another version that is reliable. What is the UDP? UDP just do something. uh, I think it's just like something person to person and source for destination port runs checksum. Okay, this person. Uh, the header is source depth and about the length and checksum. Why is there UDP no connection? No connection establishment, simple, small header size, no congestion control. Can blast away as fast as desired is it for the multimedia, streaming multimedia, yeah. Go detect errors. For example, flipped bits checksum is transmitted. Okay, sender. Okay, what is the checksum total in transmit? Trade segment contents including header, fields, checksum addition, once complement sum on segment contents. Sender puts checksum value. Sender, okay, should be focus. Sender trade segment contents including header fields. Okay, the first thing is that I should understand the output and then check. Okay, the checksum means that we just use some strategy then to find the errors and then to abandon the error things. Okay, what should I do? Flip flop, flip flop, flip flop. Encapsulate. Encapsulate. No, it doesn't. The first A. Because when we just check the specific information, then after check we just abandon just for if this design just for efficiency. What is the purpose of UDP checksum to detect the error in transmitting and what is the process? Just a second. I don't know what is the specific what is there is the source port also IP or source port, destination port, length, data length, and checksum. Connectionless. It's just very simple, it's not a structure, but step to step, just heap, I think. And then we'll go deeper into the transport layer. Okay, the half path. Repeat. Transport. We'll learn about the why it is reliable, how to guarantee reliable and some control. Okay, this one is about the principles of reliable data transfer. Principles of reliable data transfer. We use TCP, reliable data transfer. Top 10 characteristic of an unreliable will determine complexity. Unreliable transfer, RDT, will determine complexity. Oh, the first thing is the thing is also about what I want to learn, then just to narrate all. We it just seems like the reading. Yeah, principles of reliable data transfer. Okay, we will learn about the principle how to guarantee. It's not about TCP, but the principle. What is the principles? What are the principles of reliable data transfer? And okay, what? The first thing is what, and the why. The first thing, the second thing is the why is important, and the third thing is how to enable to make them. Okay, there's another information characteristic of unreliable channel will determine transfer protocol. RDT, reliable data transfer. RDT means reliable data transfer. The service implementation provider service. What is it? This is some model, very easy thing. Don't think they are many different things, many things. But I think now it's very easy. FSM, finite state machine. We talked about a lot about this finite state machine. A finite machine shows how a state system works with states and transition between them. Okay, the first thing is out what is a finite. From your understanding, what is a finite state? I think it's just mapping some state connect with some input. I think. Unlocked. Locked. So why it is important? We just introduce this concept, finite state machine. I think basically, I think I will do some state changing. RTT. How to guarantee RTT? How could you guarantee if you are the designer how to guarantee reliable data transfer? I think I will add more mechanics like RDT. I will introduce more mechanics. So the first thing is analysis the presence. What I have learned, what we have now, it's just about the huge structure that is to say send information like the header and the data, and so that we can one process, two process, cycle. We have the multiplex and demultiplex, and we have gate, so that we can. So what is the reliable? Why we want the second thing is out. What is the problem? The problem is that we don't have the how to guarantee we just lost if the bits lost in the physical law or something like we just delay, we just queue or something. So this is so if we can't avoid this problem, so how to have more implements, like more implements to solve this, to prepare for the potential problems, so that we will introduce that feedback. So we must, if we don't want to feedback, the better way to, we don't want to affect the original efficient high efficiency. So we just, if the ideal is the same as the original, but if there are problems like errors, we just use more no free lunch. So I think we should introduce week and then two refills. Okay, so why we FSM is just to means that feedback receive continue feedback receive continue feedback. No, stop, repeat. Okay, this is just a FSM. Okay, I have learned. So I think what we have learned. So I think it's a little poor. So could I please add more and to make it, to polish it? Yeah, I think there are a lot of things to do, like how to build it. It's building, so how to make it more beautiful and more high efficiency, high efficient. So what should I do? Oh, these are just what I have learned, but others is like, okay, introduce, break the whole building and then use other things like quantum mechanics, quantum channel, so that we build quantum channel out of different mechanisms, so that oh, there are additive 1.0, 1. Okay, I think this are just some difficult point, and now I think there are different versions. Okay. Directly 1.0, we do nothing. We just think that. Oh, what is the state machine? Final state machine means that the next date uniquely determined by next event. Underlying channel may flip it in packet. Negative acknowledge retracement. I know fetal flow. Oh, there is another thing that if it doesn't fetal flow, there is another question. We need a clock. Sequence number to each packet receiver. Duplicate. Fetal flow. Stop wait. Sender sends one packet, then stop wait is about the RDT. 3. Oh, the 20. Okay, the first is okay. If the sender is in wait, repeat, okay. Repeat the last. Oh, 2.1 sender handcraft. I don't think this map is very well because the different part. What we have introduced is that the 2.1 sender. But remember, reasonable time. The first thing is the arrow, the ACK arrow, and second thing is the data arrow. Extension number. It confirms the screenshot ACK cannot remember. Time out. Okay. I think the last part is not well, just some mechanics. Not really a big deal. I think it's just like a mechanic we learn about making very easy thing. Then I will deal with the quantum computing. Oh, it's a fall. Okay. Goodbye.